Good morning. In the last video, we have discussed about the introduction to the coordination compounds and the IUPAC nomenclature of coordination compounds. In the coordination compounds, we especially know about the interaction between the ligand and metal. In this video, we are going to see about how the ligands and the different types of ligands, and we can going to see how the coordination compounds can be IUPAC nomenclatured, and the basis of the different steps can be carried out to know the different coordination complexes. Okay, first of all, I'm going to see about what do you mean by the ligands. The ligands, which are nothing but an ions or the molecules, means here we can going to know the difference between the ions or the molecules. Okay, we can there may be the molecules which donate at least at the pair of electron, means we can going to see about the atoms or molecules, the ions which can going to be the bond with the coordination center or central metal atom or ion, which can be referred as the ligands. Means here there may be the respective the molecules which can donate at least a pair of electron with the central metal atom. We can going to form the coordinate bond, which is nothing but the coordinate bond can be formed based upon the central metal atom. That to form that is the coordinate bond will be formed, which is nothing but can going to be called as the ligands. Here ligands are attached to the central metal atom, means there may be the metal is going to be bind with the ligand. Here you may going to see the ethylene diamine. Here you may going to see the simple molecule. There may be the chloro or amino, which is nothing but the large molecules, such as, means there may be the simple molecules which can also be occurred in case of the ligands, and there may be the large molecules. There may be addition, means there may be a CH2 means there may be which can be CH3 which can be binded with the amine, and here also there may be NH, means there may be the bulk molecule, the large molecules, okay, which can going to be binded with the respective. There may be a formation of the coordinate bond. Okay, once again, the ligands are the species with lone pair of electrons that form the coordinate covalent bond with a central metal ion. Okay, these are all the sum of the respective ligands. Here the water molecule and the chloro and amine and carbonyl and cyano, means these are all the different types of ligands. And here in case of what are the ligands which can be present in the coordination compounds? The ligands, there may be which contains at least a lone pair of electrons. There may be an atom which can know with the respective which provide a pair of electron for bonding, which can be the donor atom. Here there may be a surrounding atoms, the ion molecule, and which can be surround around the central transition metal, which can also be known as the ligands. And there may be ligands acts as a Lewis base, which can donate a electron pair to the respective transition metal, which is nothing but the dative bond. Okay, there may be the dative bond or coordinate bond formed by the respective ligands with the transition metal ion as these compounds, which can be called as the coordination complexes. Here for any type of ligands, there may be the bonding between the metal and the ligand, and there may be at least a lone pair of electrons which can able to form a coordinate bond, covalent bond or dative bond, which is nothing but with the respective central metal ion, which is nothing but ligands. Okay, the ligands which can also be classified based upon the donor atoms. Here the ligands can be classified on the basis of the donor atoms. What type of the donor atoms which can able to based upon the on the basis of charge you can going to be known through the positive ligands, neutral ligands, and the negative ligands. And we can also be classify on the basis of the number of donor sites, and on the basis of bonding we can going to be seeing the respective the chelate ligands and ambidactic ligands. On the basis of the charge we may going to classify negative ligands, positive ligands, neutral ligands. Here there may be a lot of negative ligands. There may be a cyano, fluoro, chloro, nitro, nitrito, hydroxy, oxo. And similarly there may be positive ligands, that is also nitro, that is nitronium cation, nitronium ion. There may be NH2H5 plus. These are the positive ligands. And similarly neutral ligands, there may be a water, amino, carbonyl, ammonium hydroxide, and methyl amine. These are all the based upon the charge we can going to classify the ligands. Here it is the monodentate, bidentate, polydentate, which can be there may be the only one donor site. It means there may be a one donor site will be present, which is nothing but there may be oxygen which can be binded with the two hydrogens. Similarly, there may be the two donor sites which can be bonded, means there may be a ethylene diamine. There may be the lot of the oxalato, means there may be two donor sites will be formed, means there may be containing based upon the donor items we can donor the sites I can going to classify the respective ligands. And come to the polydentate, there may be more than the two donor sites, EDTA, which is nothing but it is also not be known as hexadentate ligand. Okay, the EDTA is ethylene diamine tetraacetic acid. Okay, and we come to the on the basis of the bonding we can going to classify the chelate ligands and ambidentate ligands. Here the chelate ligands, which are nothing but they may going to form the one coordinate bond with the respective, there may be the formation of the ring. Here there may be a metal which can be forming with the respective coordinate bond. Okay, there may be the bidentate more than the respective 2 to 3, means the polydentate ligand which can form the respective coordinate bonds. Okay, coming to the ambidentate ligands, there may be containing the monodentate ligand. Here the ambidentate ligand, which is the thing but there may be the metal which can be binded with the nitronium, means the nitro group, and here also thiocyanate and isothiocyanate. Okay, and cyano, there may be the respective the nitrate, means here there may be the monodentate ligand which contains a more than one coordinating atom or donor atom. Okay, this is how we can going to classify the ligands on the basis of charge, on the basis of the number of donor sites, and on the basis of bonding. Okay, here they're based upon the different criteria to be followed to classify the respective ligands. Okay, we can go in detail. There may be types of ligands. There may be anionic ligands and the cationic ligands, as well as neutral ligands. Okay, anionic ligands cyano, bromo, chloro. The cationic ligands nitro, no plus, and neutral ligands carbonyl, water, and amino. Okay, and the ligands, which is the thing, but we can going with the respective, we can going to be classified, that is the mono or unidentate ligands. Okay, here there may be the monodentate ligands, which is nothing but which contain ligands which is having a only one atom, which can bind it with the respective coordination center. Okay, there may be, you can going to call it as the unidentate or monodentate. We can going to be taken an example of the water. Okay, and one metal, the metal which can be binded to the two lone, means one atom we can going to be binded, means the which can be the call it as the coordination center. Okay, and only one atom will be binded to the respective coordination center. This is the pictorial representation of monodentate ligands. Coming to the bidentate ligands. Here, the bidentate ligands, which is nothing but the ligands which is having a means which is having a two donor atoms. Okay. Here, coming to the taking an example of ethane 1,2 diamine. Okay. Here, there may be a oxalate anion. Okay, oxalate ion, which is nothing but a there may be a which can going to be form a means which can going to be form a two atom with the respective central atom. Okay, and we can going to be specifically you can going to call it as the which can going to be separate the two donor atoms. That can be called it as the bidentate ligands. This is an example of the bidentate ligands. Okay, which is nothing bidentate ligands, which are nothing but which the ligands which contains a two donor atoms. Okay, there may be a the donor atoms, which is nothing but the respective the formation means the respective donor atoms can be present in the respective molecule. Okay, and there may be the oxalate ion. Okay, the oxalate ion, there may be the two oxalate ions can be formed. Okay, this is how we can going to call it as the bidentate ligands. Okay, coming to the polydentate ligands. What do you mean by the polydentate ligands? The polydentate ligands, which can be the ligands which coordinate with the central ion, there may be a more than two donor atom present in the molecule is called as polydentate ligands. Okay, there may be a you can going to be no more than two. Okay, 2 to 3 or above 3. Okay, which is nothing but here we are going to take a example of means here many donor atoms can be bound to the respective coordination center, which can be referred as the polydentate ligands. Here we are going to take an example of EDTA, ethylene diamine tetraacetic acid. You can going to be take an example. Okay, there may be the 4 oxygen atoms and the 2 nitrogen atoms can be present in the respective EDTA. Okay, these are all the common polydentate ligands. We can going to observe the bidentate ligands. Okay, here there may be the 2 donor atoms. Okay, there may be 2 donor atoms which contains 2 donor atoms, which is nothing but an ethylene diamine, which can also be can specifically we can represent it with the En. Okay, here also bipyridyl, there may be BPY. Here also acetate, oxalate, acetyl acetonate, ACAC, glycinate. These are the some of the respective examples bidentate ligands. Coming to the tridentate ligand, there may be a diethylene triamine. Okay, here also there may be a more than 3 donor atoms. Okay, and hexadentate ligands. Okay, hexadentate ligands, which is nothing but more than 2 or 3. Here EDTA, this is nothing but ethylene diamine tetraacetic acid. There may be the N which can be binded to the respective acetate. Okay, there may be the respective the donor items more than the 2 to 3. Okay, these are all the some of the examples of polydentate ligands. Next, we can going to be specifically there may be the monodentate ligands, the types of ligands, the name, and we can also be known the abbreviations and the donor groups, which are the donor groups present in the respective ligands. Okay, coming to the monodentate, the water and ammonia. We can also be aqua and amine or the abbreviations for the respective ligands. Here the donor groups, which can be the arrow mark showing the donor groups. Okay, monodentate, which consists of a one donor atom. And here also ammonia, there may be a consists of N is the donor atom. Coming to the bidentate, ethylene amine, there may be ethylene amine, which is nothing but there may be consists of a 2 amino groups. Okay, there may be nitrogen, there are 2 the respective donor atoms can be present. Coming to the oxalate, there may be 2 O groups, which can be showing here with respect to the two donor atoms. Diethyl glyoximate, which can be, there may be N correspondingly binded with the carbon with a double bond. There will be N showing the different donor atoms. Coming to the tridentate, means tridentate, which is nothing but there may be consists of a 3 donor atoms. Here the example which can be arrow showing the different donor atoms. That is 3 donor atoms can be present in the tridentate. And the tetradentate, there may be example is triethyl tetraamine. Can also be abbreviated with the trine. There may be a 4 donor atoms can be present in the respective tetradentate ligands. Next, we can move on to the chelate ligand. What do you mean by the chelate ligands? Okay, we all seen with the respective, the ligands can be classified on the monodentate ligand, bidentate ligand, and polydentate ligand. And similarly, we can going to see with the chelate ligand. Okay, what do you mean by chelate ligands? Okay, the chelating ligand is a ligand which is nothing but there may be the respective central atom. Okay, respective central atom which can be the metal ion which can be binded with the, means the bond with the, there may be a formation with the 2 or more donor atoms. Okay, coming to take an example of here, there may be the metal which can be binded with the 2 donor atoms. Okay, here the chelating ligands which are also be known as, there may be the bidentate or tridentate ligand which can be attached to the same central metal atom or ion. There may be 2 or more donor atoms forming with the respective structure. Means you can going to call it as the chelate ligand. Okay, here we can going to see the NH2 which can be binded with the methyl. This is the respective metal which can going to be formed with the, means 2 donor atoms. Okay, the atoms can ligate with the metal ion which can also be known through the denticity of the ligands. Okay, these are the respective donor atoms which can be binded with the metal. Okay, and coming to the ambidentate ligand. What do you mean by the ambidentate ligands? Here there are also the monodentate. Here we are going to be seen the monodentate ligands can be having a 2 donor atoms. Okay, or we can going to be seen there may be the respective thiocyanate. There may be a thiocyanate and isothiocyanate. Which can be binds with the nitrogen and which can be binds with the respective sulfur. Okay, here there may be we can going to take an example with the monodentate ligand, because there may be consists of a single donor atom. In this the chelating ligand, there may be the formation of chelates with respect to the that may be 2 donor atoms. Okay, here the central metal of the ion which can be binded with the, there may be 2 or more donor atoms. Okay, here also similar type of N will be the respective 2 donor atoms. Okay, this is how we can going to be seen with the difference between the chelate and ambidentate ligand. Here the chelate ligand which is having a 2 or more donor atoms which can able to form a bond with the central metal ion, and ambidentate ligand which can be the respective, there may be only thing is the monodentate ligands can be made into the, means bind with the respective metal. There may be the metal which is having there may be the formation of the coordinated bond with the respective metal. And here we can going to see the thiocyanate and the isothiocyanate. This is the thiocyanate and this is the isothiocyanate. Here there may be a nitrogen atom. Okay, we can going to be seeing the example with the SCN. That is the respective ligand which can be binded with the nitrogen atom and also sulfur atom, which can be reverse of the isothiocyanate. okay, which is nothing but we can going to be representing the resonance structure, which is also we call it as the ambidentate ligand. Means the ambident ligands which can able to adjust with the both the characters. Okay, this is how we can going to be seen the chelate ligand and the ambidentate ligand. We can move on to the next slide. There may be yes, we can going to list out the some of the common ligands. There may be anionic ligands, and the respective the anionic ligands names can be followed. Means here the negative ligands can be ended with the O, that is Br minus bromo, F minus fluoro, O2 minus oxo, OH minus hydroxo, Cn minus cyano, C2O4 minus oxalato, CO3 2 minus carbonato, CH3CO minus acetato. Similarly, the neutral ligands amino, water, nitrosyl, carbonyl, dioxygen, dinitrogen, pyridine, ethylene, diamine. Similarly, you can going to list out the anionic ligand and the ligand name and the neutral ligand and the ligand name. Okay, this is how we can going to be seen the what type of the anionic ligands and how we can going to be call it. And similarly, we can going to see the some of the cationic complex, anionic complex. We can going to call it as the in case of the cationic chromium, and in case of anionic chromate, zinc, zincate, aluminum, aluminate, iron, ferrate, copper, cuprate, cobalt, cobaltate, lead, plumbate, silver, argentate, tin, stannate, gold, aurate, platinum, platinate. Okay, there may be the metal which can be acts in the both cationic complex as well as anionic complex. Coming to this is the chelating ligands. There may be a two donor atoms which can be bonded with central metal ion, and this is the ambidentate ligand which can be observed in case of the bonding with the nitrogen as well as sulfur. Okay, means which can able to undergo with the respective ligands, and how we may going to call it is the ligand name. Okay, this can be observed in this slide. Then we can move on to the next slide. IUPAC nomenclature of the coordination compounds. How we can go to be, we are already discussed in the last video. There may be a lot of the respective rules can be followed to name the coordination compounds. We can go with the detail. Okay, how we can going to nomenclature the coordination compounds. First, we are going to take an example. Okay, this is the respective complex. There may be consists of a one the respective anionic anion. Okay, and there may be the chloro which is acts as a ligand, that is negative ligand. This is amino, that is neutral ligand. Okay, and this is the cobalt, this is the metal ion. Okay, here there may be the first thing is you can going to see with the respective there may be consists of the cation, that is the cobalt here, and the anion is nothing but a chloride, and the chloro which is nothing but a negative ligand, that is also ligand. There may be a neutral ligand which carries a zero charge. There is no charge for the neutral ligand. First, we are going to take in, there may be the 5 amino, means there may be the amine which is bonded with the respective can going to be bonded with the metal ion, and there may be a 5 ligands can be bonded with the respective central metal ion. Okay, there may be a first we are going to name the respective coordination compound. Here there may be a name of the cation appears first. First thing is in this complex we can going to be taken, means that is nothing but we can going to list out, means we can going to first choose the respective cation, and the anion is named next. And here also there may be a ligands are listed alphabetically before the metal, and prefixes denoting with the number of a particular ligand or ignored with the alphabet. Here we can going to take an example. First we are going to take the respective the number of ligands. that is 5 in number. Penta, amine. Next, negative ligand, that is chloro. And next, central metal ion, cobalt. Okay, here there may be a presence of -2 and -1. Okay, and -3. Okay, this is 5. There may be the neutral ligand having a 0 charge. Okay, there is no charge for negative neutral ligand. Okay, here -2, -1, -3. There may be the cation which can be neutralized, means it can go be neutral with the respective anion molecule. Okay, here the -3 can be neutralized with the +3. Okay, here we can going to be -2, -1, and there may be a possible charge of this cobalt is 3. Okay, there may be the cobalt which is having a +3 oxidation state. Okay, then we can going to name it as the pentamine chloro cobalt 3, and the respective the anion, that is the anion is named last, that is chloride. Means we can going to call it as pentamine chlorocobalt 3 chloride is the name of the respective coordination compound. Then we can move on to the one more example. Here we can going to take an example of the respective sodium. Okay, first thing is sodium, that is the cation, and anion, that is the chloro is the respective and also the molybdenate is the metal ion. Here there may be the 4 chloro ligands can be present and 1 oxide ligand can be present, and the molybdenum is the central metal ion. Okay, there may be a -4, and means -1 is the charge for chloro, and there may be 4 possible the ligands can be binded with the respective central metal ion, and we can going to be 1 oxo. Okay, oxide ligand is also present. Okay, yeah, then +4, -4, the sodium which is having the respective +2 state, oxidation state, and here also we can going to be observe the molybdenum which is having a 4, means which can be neutralized with the respective with the negative ligands. Okay, we can also be called a tetrachloro oxo molybdate 4. Okay, coming to the one more, that is the potassium ferrocyanide. Here we can going to name it with the, this is the coordination sphere, that is the negative ion, and this is the coordination number, the number of ligands, which is nothing but an coordination number, and this is the iron molecule which is having a central metal ion which is also be acts as a Lewis acid, the cyano which is acts as a ligand which is also be Lewis base, and the potassium is the positive ion. Okay, coming to the respective cyano ligand. Here the cyano which is having a minus charge, and the complex which is having a -4 charge, balancing with the 4K plus ions, and here -6 plus 4. Okay, 4, here there may be a negative ligand for -6, and there may be a 4, -6 plus 4, 6 minus 4, which is nothing but a +2, means the iron having a the respective oxidations, iron must be +2, and we can going to be measure, means here first thing is the cation will be first, potassium hexacyanoferrate. Ferrate means there may be a the ion which is nothing but an cation, ferrate. Here iron can also be named as the ferrate 2. Okay, here also be common name of this complex compound is the potassium ferrocyanide. Okay, this is how we can go to nomenclature the coordination compounds. Okay, first thing is we can going to be name the cation which is appears to the first. and the unnamed is lost. And ligands are listed alphabetically, and prefixes can be denoting with the number of particular ligand, which is when alphabetizing. Okay, and we can move on to the next slide. These are the some of the nomenclature of the coordination compounds which can be found below. Here also there may be a potassium hexacyanide ferrate 2, means this is the -6 and +4. Okay, there may be presence of 2 ion. And similarly, you can come to the tetracyanonickelate 2 ion. Here also we can going to take a cyano, which is nothing negative ligand. That is, there were 4 the ligands. Okay, tetracyanonickelate 2 ion. Similarly, tetrahydroxide zincate 2 ion. Similarly, we can going to take carbonyl. Here, in case of carbonyl, water and amino, those are which is having a negative, means neutral ligands. There is the zero charge. Okay, the ligands must have zero charge here. And similarly, you can move on to the sum of the. Similarly, you can go to potassium, iron, platinum, cobalt. Okay, these are the some of the types of the respective the coordination complexes. Here also same similar type of the respective the complexes can be appeared. You can going to be seen, means the how we can going to be seen. Here also some of the examples which can be going with the respective coordination number and the oxidation numbers. Okay, you can see easily we can going to know about the coordination number, which is the number of the respective ligands can be found, and there will be the respective the code oxidation number can be calculated. These are some of the examples. Similarly, we can move on to the isomerism. Isomerism, which is can be divided into, means there may be a arising with the different in the structure of the coordination compounds. That is structural isomerism, and the stereoisomerism, which is arises due to the spatial orientation, which can be seen under the ligands around the metal ion. Further structural isomerism can be classified on the ionization, hydration, and linkage and coordination isomerism. And stereo can be classified based on the geometrical and optical isomerism. Means the isomerism means what is the isomerism, which can be seen in the coordination compounds, means which is the 2 or more compounds which is having a same chemical formula but a different arrangement of atoms, means there may be a arrangement is the differ from atoms. Okay, this can be observed in case of coordination compounds. There will be a predominantly we can going to exhibit the type of isomerism in case of stereoisomerism and structural isomerism. Here stereoisomerism, what do you mean by stereoisomerism? The coordination compounds which exhibits with the same chemical bonds which is having is different spatial arrangement is called as stereoisomers. Further, it can be divided into optical isomerism and geometrical isomerism. Here we can going to be optical isomerism is which is the isomerism which forms with the non-superimposable mirror, which is nothing but an optical isomers or enantiomers. There may be the 2 types of the respective isomers can be named. Means one is the dextro and another is the levo. Means there may be a dextro, means which can be rotates towards the non-polarized light towards the clockwise direction, which is nothing but a dextro. And there may be a which can be the isomerism that rotates plane polarized light which is the anti-clockwise direction, which is levo, that is also designated with the L. And there may be this is an example of dextro isomer. Okay, this is how we can go to see in the levo isomer. Both D and L isomer which can be the racemic mixture. This is how, means we can going to see the respective optical isomers. Then we can move on to the geometrical isomers. Geometrical isomers means which can be observed in heteroleptic. Means which is having a more than one type of ligands. There may be a which can be observed in case of the coordination compounds which is having a coordination numbers 4 and 6. Means the 4 which is nothing but a tetrahedral complex case can be observed. Okay, here we can going to see the both cis and trans. Okay, and which can be in different directions. Okay, this is the we can going to be seen the respective tetrahedral structure and square planar structure can be observed in the respective the ML4 means metal ligand with the coordination number which is nothing but in tetrahedral complexes, and ML6 metal ligand there may be a 6 in the coordination number which is having a the central metal ion which can be binded with the 6 ligands, means 6 donor atoms. Okay, here there may be in case of the amino and the chloro, both the ligands can be attached with the respective central metal ion, which can be observed in case of cis and trans. Means cis which can be the isomers are the same in the respective side. Trans will be the respective which can be attached with the different groups in different form. Next, structural isomerism. What do you mean by structural isomerism? Which is nothing but which are also be appear in case of coordination compounds. There may be having a same chemical formula but the different arrangement of atoms. Okay, there will be a different types of arrangements can be observed. That is a linkage isomerism. First one is the linkage isomerism. Second is coordination and ionization, solvate and ligand. There may be the 4 types. There may be one more is the ligand is the another type of the isomers. Okay, here linkage isomerism which is exhibited by the coordination compounds having a ambidentate ligands. Means the ambidentate ligands which is nothing but there may be a 1 and 2 the respective the 2 donor atoms. Okay, and the 2 ligands can be possible in case of linkage isomers. Okay, which can be exhibited the respective link with the respective the ligands. Coming to the coordination isomerisms, there may be interchange of the ligands between cationic and anionic entities, which can be appeared in the coordination compounds. There may be we can going to take an example of cobalt complex and the chromium complex. There may be a chromium and the cobalt. Similar, there may be a coordination with the different ligands, and there may be a change in the arrangement of the central metal ion. Coming to the ionization isomerism, there may be the respective ionization can be arises when the counter ion in a complex that is which is can be a potential ligand which can replaces the ligand, which is in case of Cr also the difference between the respective the bromine is outside the coordination sphere. In here there may be inside in the coordination sphere. Okay, this is can be observed in case of the ionization of isomerism. Okay, next we can go to the solvate isomerism. What do you mean by solvate isomers? There may be solvate isomers in case of ionization isomerism in which compounds differ in the depending on the number of solvent molecules. Here there may be solvent water, here also water, here also water. Means there may be a which can be depend upon the number of solvent molecule which can directly bind it with the central metal ion. Okay, this is how the solvate isomerism can be explained. And the ligand isomerism, there may be a isomerism which can differ in the different ligands which can be binded. The amine is binded with the respective the molecule. Okay, this is how with the difference between the structural isomerism and stereo isomerism. These are the some of the geometrical types of the respective metal ligand. Means the coordination compounds which is having a square planar which is coordination number 4, and coordination number 4 tetrahedral, coordination number 6 is the octahedral. And these are the some of the coordinated complexes with the coordination number. There may be a coordination number 2 which is having a shape is linear, and this is the shape and some of the examples for the coordination number 2 and the coordination number 4. Please bear in your mind, there may be coordination number 4 is the very important. Okay, this is square planar, and there may be some of the examples, and coordinate number tetrahedral, these are some of the examples, and octahedral, which is having a the respective the copper as well as the vanadium and the cobalt. These are some of the coordination number which metal is ligated with the 6 donor atoms, and here 4 donor atoms, here also 4 donor, here 2 donor atoms. This is how we can going to know about the ligands and the different the types of the ligands we can going to see, and we can going to observe the how we can going to nomenclature the IUPAC nomenclature of the different coordination compounds, and the respective the difference between the stereoisomerism and structural isomerism, and different types of the classification can be observed, and the different coordination complexes with the coordination number can be observed here. This is about the ligands and the different types of ligands. Okay, thank you for watching this video.